Okay, so I'm working on this project now. I want to make CR30 print mill as good as possible. So I fixed some problems, I used some remixing and I made some my parts, and this is the final result. So it's running Clipper on the original board. We have 7-inch screen, touch screen for Raspberry Pi. Everything works. It has a Revo A3D nozzle and system with nozzle for belt printers. Cooler for hot end and heat break is stock. I have added direct extrusion from a model that was already available online. Now these holes are for linear rails, but it will be installed later on. Now filament sensor is moved to the center of this printer. Now I am using this like movable letters, stairs to climb and change filament, put it in extruder, and so this is how it looks. Now we can have up to 2 or 3 spools here with 1 kilogram. This is removable. You can unscrew this from this side and this from this, and then you can take it out or put it in. Then you can screw it again back and it will hold in place. So now when I need to move printer from the wall to the fixing area, I retract the filament, put it in the spool and remove the spool, and then I can easily remove the printer, but with this spool I cannot remove it. So we have wall mount here, and this is my part. This is original part from the internet, and throughout this video we will see how to do these updates and where to download these files. Now this part here is also from the Thingiverse, and this is like switch if the belt goes too much on the one or other side, switch to pause or stop the print. But in Clipper I could not make it work through already available pin, so we will see about that if someone from the community can help with this. All the files, Clipper bin and so on will be available for download, so that you don't have to hustle in order to put and install Clipper on CR30. First thing that we will have to do is to find RX and TX connectors on the Creality board. Since Creality board is made to be as cheap as possible, it does not have extra connectors for RX and TX signals, so we'll need to hijack them from the chip that is communicating through micro USB port. We have pinout of the chip CH340C. First pin is ground and it has circle above it. Then we have second and third pin, and those are the pins that we need, RX and TX. We will need to identify them, and when we look at the original the picture of the board, we can see that top left corner has the circle, and that's the first pin or ground. Then the two below it are TX and RX. In this picture we can see the circle, and below that is the pin 1 and its ground, and the other 2 pins are what we need, TX and RX. In Raspberry Pi it is more clearly defined that we don't need to hijack anything. We already have external connectors for RX and TX, GPIO 14 and GPIO 15 pin, or pin 8 and 9. What we are going to do next is we will need to solder wires on Creality board directly on the chip, and we will need to connect it to Raspberry Pi. I decided to use modular connector so that I can plug and unplug this cable from Raspberry Pi. Now I'm going to draw the connection. We can see the schematic here, and we can see the chip. First chip on the right side, first leg on the right side of the chip is the ground pin, and pin 2 and 3 after that are RX and TX pin that we need. Now, when Raspberry Pi is communicating with Creality board, it needs to have closed loop of communication. It means that if Raspberry Pi is transmitting something, Creality board needs to receive it, and if Creality board is receiving something, then Raspberry Pi needs to transmit it. And R stands for receiving and T for transmitting data. So we will need to connect TX from the Creality to the RX of Raspberry Pi, and we will see that later on. Now I am trying to illustrate how this connection is going to happen. If we analyze pinouts of Raspberry Pi external pins, we can see that pin 8 and 10 are pins that we need. First 3 pins from left to right, on the left upper corner are for powering Raspberry Pi, and 4th and 5th one are RX and TX pins or connections. Now I am writing what is happening. We are connecting TX of Creality to RX of Raspberry Pi and RX of Creality to TX of Raspberry Pi. It is in reality a straightforward process, but it should be done right first time, because we don't know what are the consequences if we mess something up and if we short the chip. So it's important to pay attention in every step of the way. I decided to use this approach because I did not want to have cables running outside of the Creality. I wanted it to be slick setup, like sleep setup and so on. Not too much wiring outside of it. Now we have completed the mission, and we can see here how it is soldered. This 4.2.10 Creality board is only for CR30 Antique. I could not find more information about it, and here is how I connected it to Raspberry Pi. When installing Klipper and Klipper firmware for CR10, we will need to do a couple of things. First, here is this side that will give us some instruction on how to do it, but we will need first to install operating system on Raspberry Pi. First things to do is to choose which board we are using. I'm using Raspberry Pi 3 board. Operating system, we will need to go under other specific purpose systems, 3D printing, and I am fan of Mainsail operating system, so I am selecting it. Choose storage, I will select mass storage, and next. Now we can use edit settings, and I am naming my username CR30. I put my password, I put like set local settings, services. You need to enable SSH, and that's about it. Now you save the settings and click yes, and then you finish putting image on SD card. Now I won't do this because this is not the card that I want to use for CR30. I'm just doing it for demonstrative purposes. Now when we have installed Klipper, we can go and look for firmware. Now to install firmware, you can follow other tutorials that are related to Creality machines. So we have one on this site. If we go at the beginning, so how to install Klipper on Ender 3 with Mainsail OS, then this is the instructions. You can follow them. Then what you will need to do is to look for chipset that your machine is using and follow the instructions. So cd Klipper, make menu config. You will need to download some things. Then when you SSH through your console, you will be able to select options that are appropriate one for CR30. To be honest, I forgot what they were exactly, but I know that I followed some instructions for classic Ender 3 installation just by googling the chip main chip name. So you make configuration and you will get the in output folder clipper elf hex and clipper.bin firmware. Then you can transfer it via SD card or you can transfer it directly through SSH window, and you will then flash the clipper firmware.bin firmware to Creality board. So after that, we can follow these instructions here. So you will need to do combinations of following these instructions in order to get it to work, because some of these sites are outdated, so to 2021 not much of things happened in this time. I mean, in updating this forum, but many things change. For example, it went from Debian 10 to Debian 11 Buster, the operating system for Clipper, so you will need to upgrade the system and so on. So if you follow these instructions here, we will then be able to get the Clipper bin and to flash the firmware on the CR30. So I had some problems with following these instructions because when I was doing it, it was already outdated, and I somehow managed to build the clipper.bin and printer CFG file. So I will share them with you, and you can simply copy them, put them on SD card, and use them out of the box. You will not have need to go through this process again, but if you want to make it yourself, you can use other resources that are available on the internet. So that's about it for installing Clipper. I will provide data and other things to you. So I have like CR30 folder, and here we can see that I have Clipper. Here are the configurations, and I also have this home part, Clipper, backup of the original installation, and I have Clipper bin, and that's the firmware that we will need. So I will upload this, and we will go to the next step then. After we have installed Raspberry Pi, the mainsail operating system, we can then use this script, Kyatsu script, to install other parts. The important part is Clipper screen and part for camera and so on. So we can see it here. We have options. We type in one and then we install things and so on. Sometimes things can be installed but would not work properly, so we can then use option 3 or 4 and uninstall them. So this is my setup that I'm currently using, and I have configured it to my liking. First we have Chrome's Nest, and it is for camera. The main problem that I had is camera would not have constant FPS, and custom flag needs to be changed to what I have set here, and max FPS to 30. So now we can see what is the device that's connected to the Raspberry Pi. USB device, we have general camera, but we need to see what is the maximum resolution of it. For YUYV, it is 640 with 480. So it will default to the maximum resolution. Now we have FPS that is counting to 20 and sometimes less, sometimes more. Before this change, it was 2 to 1 FPS or no picture at all. Printer configuration is the main part that needs to be changed. You need to set stepper X and Y to your liking, because not every machine has the same X and Y movement abilities. Sometimes it's 1 millimeter more or less, and so on. I did not touch anything on set axis. We have filament switch sensor. Spool is the original part of the printer configuration. I have added switch sensor belt so that we can use the upgrade part to see if the belt is moving too much on left or right side, and pause the print until we fix that problem. The first problem that I have is the MCU. I had to add serial dev TTY AM A0, and I had to change those options so that the printer and Raspberry Pi could communicate. That's probably the main problem that I had at the beginning until I solved it. After this, we can use PID calibration to calibrate extruder and hotbed. So those are some of the main problems and solutions that I did. It would be good if someone is good enough with Klipper so that he can make a code that so that we can utilize the left and right switch to see if the belt is moving. Next thing is Idea Maker software. We can download it from Idea Maker site. This is the software that we will be using to slice parts for this 3D printer. This slicer is unique and it has some functionalities that other slicers do not have, like adding texture. And it is more like robust, in my opinion. But there is a learning curve to it. It is not easy to learn or transfer from Cura or other slicers to this. So I had downloaded this profile and I have modified it to my liking because I had some problems while working in it. So I will upload template, print your fixed reality so that you can download it later on. If you go to manage templates, we can then edit templates and make new templates and build upon existing templates. So I did not touch anything in layers settings. In extruder settings, I change extrusion width, and since I'm using 0.8mm nozzles, I changed that also. I am primarily printing PETG, so I am using 70 degrees for hotbed, and for primary extruder I'm using 255 degrees Celsius. Next thing is post-processing G-code. With this original profile that I downloaded from Idea Maker library, these errors occur to me, T0, M1001, M1002. To remove any errors, if you encounter them later on, you just type in the name of the error and we use remove all occurrences of source, and the custom line of code will be added, and then it will remove any G-code of that nature in post-processing of the G-code though. So the next thing that we will do is we will see how to connect this, how to connect the printer to Idea Maker or Idea Maker to printer. So what we will need to do is next. We will go to printer, we will go to printer settings, and we will select Marlin. This is only for Klipper firmware. Then we have export to local disk or upload to other server. We then select Octoprint server, and we will need to set up our URL for printer and API key. We can get API key if we copy access/access/API key to the IP address on the local network of the 3D printer. We move those copy code to the end, and it will direct us to the API key. We copy API key without the exclamation marks, and we paste it into the API key space. We save it, and that's it. Next thing is downloading custom parts. You can find these custom parts on my site. I have uploaded them to Thingiverse for easy access and storage and so on. So we can see what are the upgrades that I have done. Some upgrades I did not modify at all. Some I made remixes, and some I made from scratch. For example, the legs I made from scratch. The sensor and direct drive is from Thingiverse. Also set belt switches from Thingiverse. Here you can find the pictures of connectors and connections, stock connections, if you mess something up. Next thing is going to Thingiverse and looking for the files that we have. So leg has TPU part and the PETG part. I printed the main body in PETG and glued it with super glue. So this is how it looks. For screen leg I have made some changes, and it is now more robust and does not and takes touching of the touchscreen relatively good. No any difficulties. Next thing is we'll see what's the next thing. We are now scrolling through my Thingiverse profile, and we can see a couple of options. So this is the leg. I was confused why the same link went to why the two links went to the same site, but I will change that later on the site. Now we have wall mount. Since I changed the back cover, I had to add some distance in order for Noctua fan to have intake. Now this is the spool holder. I remixed this another Prusa 3 spool holder, and it was good for wall mount because it is horizontal when mounted on the wall. So removing and adding filament is easy. Now this is the remixed screen holder, and those are the parts that I have designed, and I have some more parts that I will upload later on. Now I have disassembled the printer and I have slowed down the video. The reason for that is that I was too fast while recording this and I need to explain what I did. So I added Noctua fan and I added other fan. This is the remix of the part from Thingiverse. The size that it was designed in was not appropriate for me. My length of the cover was 38.5 centimeters, and the one from Thingiverse was like 1 centimeter longer, so I had to remix it. Now I have made the fans modular, and this is how the Raspberry Pi connection looks like. I have designed this remixed this custom case, and it will be uploaded also so that you can use it. Now this connector that I will be touching now is the upgrade part for belt misalignment, and I have changed the place of connection for this connector. I have moved it above the Epsilon connector because it had empty slot there, and I used the 3-part connector, not this 2-part. So I was tinkering about this option, this limit switch for belt misalignment, and I did not manage to find a solution for it. So if anyone has any suggestions, please write them in the comments. Okay, so we have finished the first part of this video and we have solved some problems. It took me 1 year to complete this first part, but it was the hardest part. I had to design legs for this 3D printer, to design extension to mount it on the wall, and to modify the back cover for fans because I did some upgrades with Noctua fans. Now, something else that I did was install Revo E3D nozzle for belt printers. When I first started to modify this CR30 printer, this Revo 3D nozzle was not available. So it is a good thing that it took me 1 year, because now I can test this printer with adequate nozzle. Next thing that was the problem was that this board of CR30 4.2.10 is board that is only used, as far as I know, on CR30. So there was not a lot of examples on how to install and make clipper.bin and I don't know, hex files so that we can run this custom clipper firmware on it. Now I did some tinkering, I searched on sites, and there was not any complete guide on how to make this thing work. So it took me some time and making some mistakes and so on, but now it works fine. So the main part is solved. We now have a printer with original board. We have a Raspberry Pi controlled board, and we have screen, touch screen, color with full colors, HD screen. Also we have a camera, so this is now a smart device, not so stupid and basic as before. So we can now directly change and modify printer configuration and make things work better. Next problem that I had was not so good support for software. The main problem for me is that I'm using Linux, Arch Linux, so when I tried to run this Gravity software for CR30 print mill, I ran into problems even if I used Wine or if I used Virtual Machine Manager with enough RAM and everything. It will crash, and it would not work properly. So what I did is I googled online, and I have seen that the best printer to be used locally without connecting it to some other server is actually IdeaMaker. So I started learning IdeaMaker Slicer, and maybe I will make some videos on how to use it properly, because there is a learning curve to it. It is not as other slicers that copy each other all the time, and there are some useful features in IdeaMaker. So three main problems are solved with this printer: nozzle, clipper, and slicer. So the next problem is adhesion. With this stock belt, I have problem with adhesion to the bed. So what I did is I sanded it with 220 size paper, grind paper, and the adhesion is still not the best. It has some problems with smaller parts and so on, and I did the bed leveling and other things. So how I tested this printer is that I printed this sword. It is printed from 2 parts, and it's like 1.2 meters or something like that. So it took me 6 days to print it, and printer worked non-stop without problems. So this proves that Clipper and Raspberry Pi and communication works fine. Some things that I would change is I would experiment with these filaments, because there is some under extrusion and over extrusion and so on. So there is things that we can fix with this printer, and if you have any recommendations and ideas what should be done next, please recommend them or make video, and then we will talk about it. So for now, this is it. We have part 1, and this printer can be made useful once again. Best regards. Oživio je.